Uh, yeah, welcome to the session. I'm Arjun Radhakrishna, and my co-host is Gustavo Suarez. And we'll be presenting some work we have been working on for quite some time now, probably a couple of years now. So let's get started. So I think the best way to do it is we'll show you a demo first, and then maybe we can go over some of the technical details. Let me start sharing my screen. Okay, share. Okay, is this visible? Is the font large enough? Gustavo?
Yeah, I think it's good.
Okay, excellent. So, so what we've built is a tool for automating repetitive edits in code. So let's sort of take a look at this example. So in this piece of code, like I have removed this type called iRepository model manager. And now I'm like eliminating all traces of it from this other class, right? So the first thing is, okay, I'll remove this constructor argument, and then there is this assignment to a variable, field variable. I'll remove that, and then there's a private field called iRepository model manager. I'll remove that. But once I remove that, there are all the usages of that particular field show compilation errors now. So for example, here I have this build model output details response. And
no, no, I think that's fine. I think this is another compilation error.
Okay, yeah. Okay, the one we wanted to look at is this one. So yeah, there is this repository model managers dot get throttling time something, right? So the change I'm trying to make here is all the places where I call a function on model, I'm going to remove the model and put it up here. So I'm moving one of the arguments, and I'm moving one of the arguments out. And Gustavo, do you know what's happening?
Yeah, I think you have to import this type.
Oh, yeah. Okay, yes. So I say Visual Studio gives me a prompt, I import that type. Looks good now. And then there's another place. It's a different method here, right? This one is called is training underway. That one was called get throttle time remaining. So, but the change is more or less the same. I remove this model from the from inside the call, and I put the model outside, right? And as soon as I do that, I now get a bunch of suggestions here. So if I go to one of those places, it says, oh, here's a suggestion. You may want to change exactly what I've been doing, right? So removing the model from inside the argument list and pushing it outside. So I can click on that and accept the change. And here again, there are lots of other places. So again, I can say, I want to make that change. And as I keep applying all of these, I'll fix all my compilation errors. So what's happening here is, while I'm making the changes, Visual Studio has automatically watched me in the background and has figured out a pattern in my changes. And it has learned this pattern and has made more suggestions based on this. And this is a technique we've been working on for quite a while now. And it's based on program synthesis. And it can do a lot of pretty cool things, right? So it can show me, like a lot of a programmer's time is wasted in doing repetitive edits. And this is one good way of automatically figuring out where these repetitive edits need to be made and suggesting changes that will apply this repetitive edit. So did everybody get what the demo is doing and any questions? So let's make this interactive, right? So I'll stop all the time. You can ask me questions. So anything here? Okay. Okay, then let me go ahead. With presentation we've made. Gustavo, do you want to take this?
I can. So just for everyone to be aware, this is supposed to be interactive. Like we didn't prepare much for that. This is basically a work that we did and published last year at Uppsala. Actually, Anders, who is the first author and was our research intern here, is in the audience. So hi, Anders. And yeah, so this is mainly the demo, but we can also go over and explain a little bit more of the technical details if you guys are interested. Let me share my, I will share my screen.
Hi, this is Tom Ball. So,
hi, Tom.
Sorry, I'm also logged in on the Rise one because I couldn't figure out where to get in. So, what was the source? Maybe I came in a few minutes late. So, what was the source? Public GitHub repos that you crawled?
No, Arjun, why don't you show again the demo really quick? So we are learning by watching the developer while the developer is coding. So there's on the fly.
Oh, it's on the fly. Oh.
Yeah. This introduced a lot of challenges. Yeah, let's do it again.
Mm-hmm.
So here's the repetitive change I've been doing, right? So I have static calls to this method called repository or to this class called,
you're not sharing. Are you sharing the screen? Wait, I don't see.
Okay, can you see this? How about now?
Yes, I can.
Okay. Yeah, so what's happening here is there are a bunch of static method calls with this object or with this class called repository model manager. And this class has been removed in this new version of the code. And I'm just fixing all calls to these static methods. And the change here is, the fix here is to move this first argument, which is always this model, and call the method on model. So the fix is usually just moving the argument model outside and calling the method.
Yeah, I think you have to import the.
Yeah, and I need to import this class, and then there are several other places, right? This is again, these are not exactly the same method. They are like different methods, but the fix is more or less the same. So you move.
Oh, I understand. So this is more akin to flash fill, learning from a small set of examples.
Yes.
Yes.
Oh, I'm sorry. Okay, I just missed that context. Yeah.
Yeah, and now you have suggestions that will tell you to apply this change automatically. So the key difference between flash fill and this technology is you don't have explicit examples. So as a user is doing all of these changes, there are of course repetitive ones, non-repetitive ones. So you have this history of edits, and the task is both to identify the examples as well as to do the learning.
And you're not doing this with any information from the compiler, like type error messages or anything. This is just by observing the edits, not using any abstract syntax, or?
This is, it's using the parser. So the objects operated on are abstract syntax trees, but we aren't using too much compilation information.
Yeah, you can show this example on line 319, right? Because you can see that on line 319, it's a similar change, but now this method actually has 2 arguments, this method call. But if you look at the suggestion, it's the changes basically delete the first argument. Yeah.
So it's not just a textual edit, but it's an edit over ASTs.
Oh, okay. Okay. Yeah. So you edit over the AST and then you unparse?
Yes.
Yes.
Okay.
Okay. Okay. Yeah. Do you want to go ahead, Gustavo?
Yes. Okay. Let me see. I have.
Oh, you've got a question in the chat? Do these edit suggestions apply across files, usages across modules, or is it only within one file?
So it currently shows the suggestions for all the files you have open, but it's not a hard extension to make it get suggestions for everything in the project or everything in a module. So currently we found that this particular interface where you only show it for the open files is the one users like the most.
Let's see the second question. Yeah, I think Anders was asking about, in the first 2 examples, there was only 1 argument. The next one has 2 arguments. So there is a balance between most specific generalization and if we are always learning from the most specific generalization, you have a lot of false negatives. Anders, actually, we have been working on to improve this technique. We had another research intern over the past 6 months. Working on a new technique that we are working on this yet. Right now, it's still the most specific generalization, but there is also a lot of ranking to help, for instance, in that case. Arjun, do you also want to show the demo? Maybe if you show the demo, it can help answer this question from Anders on where we are going next with the 1.1 example. Do you have this demo with you, Arjun?
Not very organized.
Yeah.
Yes.
Yeah. Can you show that one?
Okay. Yeah. I will share. Sorry, I'm not really using to. Host disabled. It looks like you're the host, Arjun, so I cannot, it does not allow me to share my screen. It says host disabled participant screen share.
If you go to participants, there are 3 dots to the right of participants, and then there should be some options there. This is only for host.
Oh boy.
So can you come again? I couldn't.
If you bring up the kind of floating list of all the participants in the meeting, there's like a sidebar that's got all the participants.
Yeah, now I think I can. I can share now.
Okay.
Okay. Let me share. Just to answer.
Want to about Zoom.
Yeah, just to answer the question from Kong, what is the role program synthesis play here? The role is that the program synthesis learns an abstraction on the concrete edits that the developer is performing, right? The developer is making concrete changes to the code, and we are actually taking these changes as examples and learning a program in a domain-specific language that represents a program transformation. So you can think about like we are learning this analyzer that knows how to change the AST that represents your code. So it's a more abstracted. We abstract the examples into programs. And Anna is asking whether it can learn from prior code refactoring logs from prior users. Yeah, let me show this demo, and we can see it like this. So hopefully the sound is working. Can you guys see my screen?
Yeah, we can see your screen.
Okay.
Let's take a look at what Gustavo's doing. He's refactoring the pros code base, and he's replacing a name tuple that denotes the cursor location in a file with a new struct called position. Not only does he have to change the type, but also the initializer for the start position property. On the next line, he has to make the same change for the end position property. As soon as Gustavo starts making this change, IntelliCode has something very interesting to suggest. The suggestion has the whole change he was intending to do. Wow, this is not just suggesting an identifier or a type change or a function name, but a complete change customized to the user and the setting. Excellent. Next, Gustavo has to change every assignment to the start or end position properties to use the new type instead. He replaces the first name tuple with a call to a factory method for position. When he goes to the next location, IntelliCode has again produced a suggestion with the full edit he was intending to do. On accepting this, IntelliCode has identified changes of this kind to be a repeated edit. It immediately pops up a blue light bulb, indicating other places where a similar change can be made. After these changes, Gustavo is done with the type migration and pushes an update. IntelliCode saved him time by reducing the amount of typing as well as by removing the need to hunt for other locations to make the same repetitive edit. Now let's take a look at the other side. Arjun is working on a project that uses pros as a library, and he has just updated the pros package to the one that Gustavo just pushed. He immediately sees compilation errors that are related to the type migration that Gustavo did. At this point, Arjun does not know anything about the new position type or its factory method. However, IntelliCode comes to his rescue with its Team Suggestions feature. It has already produced suggestions to fix the compilation errors by transferring the edit patterns learned on Gustavo's machine. Accepting these suggestions, the project builds with no further problems. This way, the IntelliCode features powered by the program synthesis framework of PROS are able to help both the library author and the library user to save time on refactoring.
This demo answer is related to the last two questions from Anna and Anders. So you can see that we have been working to learn how to generalize the transformations from just locations as well. Like the user makes one change, but then it goes to the next change, although to the next location. Although we do not have a suggestion in that location, we can take that location as a partial example to increase the generalization of the programs that we learned before and produce a suggestion to that location. And we are starting to work on how we can share these suggestions among different developers. So we learned from one developer in the demo, and we showed the suggestion for other developers. Any questions about the demo? Let me see. Sorry, I do not use Teams this very often, but okay, I can just chat. Okay, found it. And there's No, and just answering the question from Anders, there is existing research on disjunctive program synthesis. We are not using this idea, Anders, because it would be too expensive to synthesize a lot of programs. So we come up with a different strategy, actually.
Also, one thing here is, as Gustavo was mentioning, so this on-the-fly learning, especially if you're showing your suggestion in this autocomplete interface, you have to return a suggestion within, like, I think 0.2 seconds or 200 milliseconds. I think that's close to the limit you can afford for that interface. So you can't do anything really heavyweight there. So especially the disjunctive program synthesis is out of question.
Yes, and Miguel's question is more related to how we can figure out, like as Arjun showed in the demo, this synthesis is in a modeless environment. So the user is not explicitly saying, oh, this is one example, this is another example. We are actually looking at all the traces and trying to figure out what are the examples. So there can be noises and unrelated changes. I'm going to show a little bit of, so I'm going to present some slides that can explain how we do this. So again, this is based on this paper on the fly synthesis of edit suggestions. It was published last year. So you can check more details there. So this is just the example I'm gonna skip because we already saw some demos. But as we can see, there is these challenges of noise and unrelated edits. For instance, here the developer is making this change in this first location. And then the developer goes to a different location and applies a second it's a related change, but it's not a repetitive change. It's just creating this is valid method that didn't exist before. But it's not what we want to automate. So the developer goes to this, make this change, and then the developer goes to another location, and then it does the repetitive change in a different way. You see that the developer can just copy and paste and change the name of the variable. So there is a lot of noise. This is one of the challenges that we had to do. I'm going to skip transient. We saw that developers can apply edits in different ways, right? In the first one, it manually typed the entire change. In the second location, we just copy and paste. Arjun, since I cannot see the chat, if you want to keep looking at the chat and interrupt me if there are questions.
Yeah, I'm keeping an eye on it.
Yeah. Another challenge that we have to deal is with respect to with this generalization of user intent. Our language may allow to represent transformations that although like it's a pattern, it's not the pattern that the user wants. For instance, if the user makes this change, just removing this method invocation and this second change where the user just remove this reference to kind, you can find a pattern there from x.y to x, but if you show this to any developer, it will say that this is not a repetitive change that I want to do. So there is a lot of challenges in this environment. So what we do, basically we keep track of every change, every version of the code in terms of an AST. So in our example, for instance, we have the initial version, and then the user start making the changes, and we create version 2, 3, 4, 5, 6. And the actual repetitive change goes from V1 to V3. It's when the user finished the change in the first location, then from V3 to V4, the user, for instance, created this method is valid, which is unrelated. It's not repetitive. And then again, from V4 to V6, the user makes the second change. So how do we know actually that the user wants to automate to create a pattern from V1 to V3 and from V4 to V6? The first thing that we do is like we represent it in, we put this, we represent these changes as a graph. So we have this tag that where every edge will represent a change from one version in the code to another version. So now we can represent every possible change that the user wants to automate. And here you can see that there are many, like it's a big problem now because we have a lot of options here. So what can we do now? How we can figure out from all these possible changes, what are the ones that are repetitive? Like the most naive approach is just to try to compare all the subset of possible changes here, which would be super time consuming. What we do instead is our second step is to identify what are the similar edits using some unsupervised learning techniques. So the idea is to find these clusters that will say, oh, from V1 to V3, this change is actually similar to the change from V4 to V6. And the change from V1 to V2 is similar to the change from V4 to V5, and the same from V2 to V3 is the same as V5 to V6. So we create these clusters of changes using a technique that it's similar to clone detection. But instead of doing clones on ASTs, we are actually trying to do clones on AST changes, basically. And after that, these groups, these clusters, actually, we use these clusters as examples for the synthesizer. So each one of the clusters we use as example, and we try to synthesize a program using a synthesizer. In our case, we are using the PROS framework, which we have been working for many years now, to synthesize programs in a GSL that represents program transformations. So after that, we synthesize these programs. We have, for instance, a program P1 that if we apply P1 to V1, it will produce V3. And also if we apply P1 to V4, it will produce V6. So we try to synthesize all these programs from using these examples. If clusters have only one instance, we do not do synthesis here. But still, after this step, we still have some ambiguities. Like, how do we know whether we should show to the developer suggestions from P1 or suggestions from P2 or suggestions from P3? Because basically we want to use these programs and run these programs on the entire code, or for instance, on the entire file, as Arjun showed, and generate suggestions. But if we run all these programs in the code base, we will produce many false positives, right? Because there are many partial changes. For instance, from V1 to V2, it's just a partial change. We do not want to show this to a user. So the final step of the technique is ranking all these programs so that we show the programs that are likely to be the correct ones. I think this is just, okay, so this is the final step, ranking. And to do so, what we do is we have an algorithm to do the least colorful path from V1 to V6. So we compute the least colorful path and show the programs in this path because we think these are the likely to be correct ones. For instance, the best path here would be the one that just used the color green to go from V1 to V3, from V3 to V4. I would just use this bottom program. We didn't synthesize any program actually. And from V4 to V6, we will use P1 again. So this is better than using P2, P3 because it has less these colorfuls. And like the idea here is that at least in the field of program synthesis, trying to synthesize, a good heuristic is to use programs that are less complex. So if we can explain this trace, if we can explain this history of changes made by the user with a single pattern of repetitive changes, it's likely to be better than representing with many patterns of repetitive changes. So this is mainly the idea. So just more details about the steps. Let me see how I'm going on time. So on step 2, what we do, I mentioned that we do this edit, clone detection for edits. We basically represent each AST, each AST change in a vector where we are basically flattering the tree of the AST, and each one of the positions in this vector represents one token in the tree and the diff in this token. For instance, if I go to this part of from this code to this code, I'm deleting. My final version of the code will have I lost one block, one open token, one open brace token, and so on. So we use this technique, which is kind of similar to other clone detections techniques. This is based. This Descartes tool is a common clone detection technique used. So it's a very similar technique. But someone can also try other embeddings to represent these changes that could also be used in the same framework. Yeah, I'm not sure if we need to go over these details. Is there any question there?
Yeah, so I think we can go over just the first couple of slides of this bit because
Okay.
there's a question about where to apply the patterns and.
Okay, do you want to go over the slides, Sergeant? I can
Sure.
you can ask me to change the slide. Yeah.
Oh, okay.
Or you can share. Let me.
Okay.
I can stop sharing.
Mm-hmm.
Okay, might be easier, and I can look at the questions.
Yeah.
But so far, I think, yeah, Miguel, let me know if you have any more questions about if we answer your question.
Okay. Can you see my screen now?
Yes.
Okay. So this is the question related to how we learn the changes and how exactly do we figure out where to apply these changes, right? So basically what we are doing is each program Gustavo showed, that is each colored edge, is basically a rule which is composed of a guard and a transformation. So the guard tells you what you need to change and the transformation tells you how you need to change it. And for this particular change, which we're using as an example, the guard really says, you need to change AST nodes that look like this, right? That look like something followed by attributes. And what you do is you change those nodes by adding this where clause. But there is this particular thing in the where clause which you are actually copying from one of the source nodes. So, so basically this already gives you, if you're able to learn these two things separately, that already gives you a good way of figuring out where exactly this change needs to be made. And the way we, so the way we actually make this change or learn this guard of where to apply these changes is to, it's a very simple algorithm. So what we are doing is, suppose this is your abstract syntax tree, and this is the node you're trying to change. Like it's a call to something dot attributes with some parameter list. And what we do is we generate lots of XPaths. So for example, you generate XPaths that say that represent this node and this node and this node. So it's like current slash child of 0, current slash child of 1, and so on. And we generate a bunch of predicates that hold for those nodes, right? So for example, this one says the current is of kind call expression, and current.child of 0 is a dot expression, and so on. You generate lots of these predicates, and then you take intersection between the predicates you generate for the input of one example and the predicates you generate for the input of the other example. And this, in some sense here, it gives you the fact that the AST is supposed to look like this because all the predicates are common between the two inputs, except for this particular node, right, where the parent and node are different. So that thing gets generalized. So you just have some identifier there before the dot. You don't have a particular identifier there. It can be any identifier followed by this. The rest of the AST has the fixed shape. So there's one hole followed by some fixed AST. So that's kind of how we learn the guards. Were there any questions? So does that answer the question that was asked?
Yeah, I think Miguel, so far he said that the explanation is good. There is one question about how this relates to GetAFix, the technique from Facebook. I think GetAFix, I think the data set in GetAFix, the label is more clear because if I'm not wrong, I think they have a data set where the examples are from a code that has some warning from some static analysis tool to the version where the warning disappears. So the examples are actually more explicit. And it's learning in the background, or it's learning in an offline manner. Another difference is that I think they learn just using the most specific generalization, which is not so bad for them because they use a lot of data. But here, since we use very few examples, it's better to learn more programs and rank these programs to not, so that we don't have the most specific generalization always. Otherwise, it will produce many false positives or false negatives. In the example that we show in the beginning, Arjun makes the changes to methods that have method invocations that has only one argument, but still we can learn a transformation that can be applied to method invocations with 2 arguments. And if you're just trying to learn using this anti-unification process from GetAFix, your transformation would be just too specific for that.
Okay. Yeah. Okay, there are more questions in the chat.
No, I think we are good.
Okay. Yeah. Okay, so I think we can mostly skip how we learn the transformation, but basically we are learning a program in this DSL, right? So this DSL says, or you either, the way you produce an output is either you select something from the input or you construct something using pieces, right? And so for example, you can say, I construct an AST tree with a particular kind of node with some children. And the children can be constructed as, or you insert a child into some other set of children in the input, or you delete a child from some other list of children in the input, and so on. And basically the synthesis here is happening by decomposition. So I think this is too much detail to go over here, so I'll skip these slides. But our programs actually look like this internally. So you see this like some huge mess, but basically it is, so it basically has these two parts, right? The guard and the transformation, except the way these things are represented is actually quite complex. And so I won't go into the whole advantages of programming by example, but the big thing we are able to do is represent the whole solution space for this problem. There are many different guards and transformations that are consistent with your example. So what we can do well is we can represent and rank this whole solution space compactly. So we can pick the best program out of this huge solution space, like really quickly, like as we were talking, in less than 0.2 seconds in most cases. And I think we can skip these bits, but do you want to go over the last part of the...
Yeah, since we have like 15 more minutes, I can just try to advertise a little bit our group.
Yeah.
Okay, let me share my screen again. Well, so now I will just briefly talk about how we do research in our group, and if anyone also have questions later or want to reach out to us, just send us an email. We have internships, research internships all the time, not just during the summer, but also any time of the year. And we are kind of a different type of research team because it's more like a blended research and engineering team. So we do research, but we also do applied research. We also do engineering. And I can talk a little bit, for instance, about this project, this BluePencil project, how it happened. So when we started this project, it was more like an applied research project because we wanted to basically use all the knowledge that we already had on the pros team, like with flash fill paper. We also had a ICSI paper in 2017 that also, it's a similar to flash fill, but to code. And we basically wanted to apply this inside of the developer division and implement a tool to allow developers to apply, to give examples to automate transformations. But what we realized soon was like we just come up with the first prototype of that, and this is the prototype, and we showed this prototype to them. We were happy. We knew that the research works. We can just, for instance, here you have all the input statements that you want to automate. You can just have training inputs and training outputs, so basically input-output examples. And if you have this, the pros framework would produce the right outputs for every location that the developer wants to automate. So we were happy with this because we knew that our framework was able to generate. We had papers on that, but when we showed this to developers, to engineers, they were like, no, this is not gonna fly. Like users will not apply. If you require someone that's coding to stop coding, go to another window, give examples of the change that they want to do, they basically will not use your tool. So you guys need to come up with a better tool, a better solution. And then like we go from this phase of more like applied research, we try to use what we had before to this second part of the project of like, okay, if what we had, we cannot use it, how we can do better. And then like we have research interns that works on these cool projects like Andres, who is in the call. He joined us for 6 months, and we work on this entire new project of how can we remove this mode, this window, and how we can be more modeless. We just want to observe the user and while they're coding, and we want to learn in this modeless way. And as we saw in the slides, it introduced way more challenges, and we have to come up with new research and new papers. So this is an interesting idea. It's an interesting environment because you're working closer to engineers. You're working closer to users on an end-to-end solution. So it involves way more constraints, and it also it creates more challenge that leads to new research. So it led, as I said, to the second phase. We wrote a paper about this. But then after that, we also, again, go back to this engineering mode now. How can we go and make this paper a real tool? The paper already have a lot of evaluation in the evaluation section, but it's a completely different beast when you actually implement the tool and you put it to real users. This is actually, it's available today. You guys can download it. It's in Visual Studio 2019 and 2019 preview. I think in 2019 it's disabled by default, but in 2019 preview, the tool is already enabled by default. But when we face a lot of challenge here to go from research to like a product, like for instance, even memory. If you look, we are learning, doing all this synthesis on the fly. And I think our first version was consuming like 600 megabytes of memory. And this was like unbelievable. Like definitely a no from the Visual Studio team. They would not ship the tool if we do not go and reduce this memory consumption to like 20 megas. So it also led to a lot of interesting solutions for that. And then like, even though we had a good evaluation when we start using the tool internally, like dogfooding in the preview versions, there was still a lot of false positives. Like, although people mentioned that it worked in some scenarios, they also said that they range in their useness. Some users also complained, said, oh, this is annoying. There's a lot of false positives. So again, there was another year of improving the tool until we get on a state where people say, yeah, it's good. We can ship this. And like we fix a bunch of bugs. And now we are getting comments that are like, oh yeah, this is pretty cool. I was showing to my teammates, or this is blowing my mind. And users on Twitter too, saying how they're happy with the tool. So it's an entire journey from the paper to the product, but it's also really fun. It's interesting because it comes to the next step, which is more research, right? Yes, there was a lot of research here involved. We have like another 2 or 3 projects running right now that requires more research, and we hire more interns to work with us on these new solutions to improve the tools and to apply the tools in different scenarios. So that's the next phase. So
I think Anders can maybe speak a little bit on his experience as an intern and how it ties in with this whole research to engineering and back to research cycle.
Well, hi, yes. Yeah, so as I said, I joined to work on work with them on code transformations, and we got this project, and I don't know, I had a very good time with it. I thought the environment was very collaborative. It was really just very fun research, honestly. But in addition, there is an element that I got at working with that team that I don't get in the same way working on more academic projects, which is this kind of third step. You know, there's a lot of research, even that includes one, even academically, but seeing then my research really go into industrial use. And also, I mean, I wasn't involved because I left the team at that point, but seeing the team put in this additional effort to actually get it into product quality was really exciting to see. Yeah, I had a really good time. I'm like unaffiliated with Microsoft, so you can trust me when I am complimenting them and my experience. And if you are interested in the team, you probably should reach out to them. But if you want to ask someone more specifically of their experiences, feel free to email me.
Thanks a lot, Andres. Is there any more questions? Cool. I think we are done then. Thanks everyone for attending the talk, and please reach us if you guys have more questions or comments. Thanks a lot.
Yeah. Thank you.